All right, and this is the shucks. Okay, so today we're going to be talking about basic greenhouse design and just a little bit of background. I did grow up working in greenhouses, but I'm not an engineer at all, and I'll probably be throwing out some engineering terms, and chances are I'll be using them wrong, so I apologize for that. One of the primary reasons I spent a lot of time in greenhouses is because we've done a lot of work in the world of vegetable grafting. So you can see some grafted tomatoes here. We have a greenhouse that you're going to see a bunch of pictures of today that we designed and specifically use for grafting plants. And our crew out at the farm grafts over 10,000 plants a year. So it's been pretty successful. So this is not really an outline, but just an overall list of what we're going to be talking about today. I think it is important to touch on why we want to grow in a greenhouse. Sometimes people ask me questions or say, "Oh, I really want to get into hydroponic growing for this reason." And I'm thinking to myself, I don't know if I'd build a $500,000 greenhouse in order to do accomplish that goal, right? So it's important to think about why you want to build a greenhouse. We'll also talk about the components of it and the structural pieces, the venting and the framing and those types of things. And one of the things that I've tried to do is sprinkle a lot of sort of real life examples, places I've been fortunate to either work at or visit, where we can talk about some of the ways the different design elements impacts the use of that greenhouse. What are we not going to be talking about today? That is high tunnels. So if you know me, you know I can ramble on for a very long time about high tunnels. These are my two favorite pictures of high tunnels that I found yesterday while scrolling through my phone. We will be talking about high tunnel design in the next webinar. So if you have questions about high tunnels, hold those. Fundamentally, I think one of the major differences between high tunnel and greenhouse design and operation is that in high tunnels, you're growing in the soil. So that changes a lot of things about when you can use it, how you can use it, things that you have to do for IPM management. Whereas in a greenhouse, you typically have a gravel or a concrete floor, right? And you're growing things in containers and hydroponics, basically in soilless culture. I did want to put some resources out there. This is one of my favorite books written by a colleague and friend of mine named Andrew Mefford. And Andrew is in charge of the magazine called Growing for Market, if you've ever seen that before. But he put this book out about 6 or 7 years ago called The Greenhouse and Hoop House Growers Handbook. Really great book to get an idea of how greenhouses work, especially from somebody that's wanting to think about how to integrate it into a vegetable production farm or a specialty crop production farm. Andrew is a vegetable farmer, and so when he spent a year gathering, data and writing this book, I think one of the things I like about it is it really comes from that lens, whereas a lot of other greenhouse books, they're very Dutch oriented and they're very focused on very high tech greenhouses, where this book gives you some nice, sort of intermediates along the spectrum. There's a lot of other great resources out there. One of the ones I really wanted to point out was Ohio State has a controlled environment ag center, and they do the tomato growers school over there. They've been doing a strawberry growers school for quite a long time. Ohio State and Chiri Kubota and her team over there are well known around the country in the world of controlled environment ag, and they've got a great website with a lot of resources, and they provide a lot of educational materials. The other thing that I wanted to point out too is that I've had the fortune of working with a lot of sales representatives at greenhouse companies, many greenhouse companies in our region, and I will say that I've had nothing but great experiences with that. A lot of these salespeople, half of their job is to educate their customers on what they need and how they're going to get there and what it's going to cost, right? And they have a ton of experience doing that. So don't be afraid to call those folks and just talk to them. The ones I've talked to are always very happy to talk to me. And they typically, even if you don't end up buying something from them, it seems like their overall goal is to help you be a better greenhouse grower and help support the industry as a whole. Okay, so why do we want to build a greenhouse? I mean, the simple answer to that is we want to do controlled environment agriculture, right? Within a greenhouse, we can control the environment better than any other place for the most part. And of course, one of the nice things about greenhouses is they are clear, so we can utilize the sun for energy and to grow plants. Obviously, with LED lighting and vertical farming becoming more popular, that adds a whole nother layer of complexity, but we'll just be talking about greenhouses today. One of the big things people like to do in greenhouses is extend the growing season or even flip the growing season on its head, right? And so do winter growing of things that typically aren't able to grow in the winter. And then, of course, a lot of the reason we utilize greenhouses is to grow high value and sensitive crops. So here's a picture of a couple little pepper plants germinating. That process is not going to go very well if you just go stick two seeds out in the dirt, outside, right? Because all the different adverse weather conditions, the soil conditions, if you want to germinate transplants and grow things, oftentimes you need to use that greenhouse. And oftentimes, with vegetables and many other crops, they need a longer growing season than our climate provides. And so we need to give them a good, 4 to 6 week start in the greenhouse before they go out to the field. So the first big question, I think, if you're talking about designing a greenhouse, and I think one of our goals today is to really give you all enough information that you can have conversations with sales representatives. You can go up to them and say, this is what I'm thinking about growing, and so I think these are the components of the structure that I'm going to need to utilize. But the first thing you need to do is think about what you will grow. And it is really important to do that. Obviously, you can get the biggest, nicest greenhouse possible, but you're going to end up probably utilizing more money than you want to or not getting such a great return on your investment. And a lot about greenhouse design is understanding what you want to grow so that you can get the size and the scope of the greenhouse that you need really just for that. Transplant production is obviously one of the primary things people use greenhouses for, especially on small and beginning farms, right? And so we can grow vegetables for ourselves. Also, a lot of folks find selling those transplants at the farmers market or through other ways can be really helpful, right? So that's a very common use of greenhouses on farms. Obviously, there's flower nurseries and folks that, take that transplant production to another level and grow flowers and bedding plants. Now, one of the things that's important to keep in mind is that, with many of these flower species, they take much longer to get up to the saleable size, which typically for Mother's Day is what you're kind of shooting for. So many of these species, you're going to have to start much earlier in the year, like January or February. And so if you're growing things like flowers, you might need a more buttoned up greenhouse, one that's able to stay warmer during really cold weather. Whereas if you're growing vegetable transplants, most of them take 4 to 5 weeks, right? And so you can start a greenhouse up in early to mid-March and be past the really cold period here in the Midwest. This is an operation near us in Kansas City, and this is a certified organic transplant production facility. And this is one of our growing growers' host farms. He has a beautiful greenhouse, and you're going to see some more pictures of it later. But Tim is doing a lot of really unique things, partly to be able to grow certified organic. That's not an easy thing to do. But also, one of the things that's important to him is really being able to manage his environment and his climate so that he doesn't have to use as many fungicides and pesticides to go along with being certified organic. And so you can tell when you talk to him and when you go in his greenhouse that he's really focused on managing that microclimate. The next step up, I've always thought microgreens was sort of like a hybrid between transplant production and food crops, right? You're really growing millions of little bitty transplants and then you're cutting those off and selling them for the purpose of food to eat. There's a lot of folks that are doing great things with microgreens out there. This is a local farm here in Kansas City. If you know Greg Garbos, he's really well known throughout the city. And he's been doing this for a number of years, and there's several other growers that are growing microgreens effectively. One of the nice things I like about microgreens is they're kind of a low entry point. If that tray of microgreens gets covered in disease or you have a greenhouse heater go out and the whole thing freezes, you basically just start another tray, right? It's a very short time cycle on that crop. And so you can flip those things over really quickly. And if you are new to growing, that can become really helpful at times. This is sort of a little bit of a mid-stage tomato grower in Wichita, and what I mean by that is he doesn't have a super high-tech greenhouse. This is just a Quonset style greenhouse. He does have cooling pads, so he's able to cool it during the summer. But what he's really doing is doing sort of mega season extension, right? So he's going to start these tomatoes probably around January, and then he's going to be able to harvest those a good solid month or 6 weeks before they start coming out of high tunnels or the open field for sure. right? But he's not really growing in the deep, deep winter because his greenhouse probably isn't built for that. And I think in his case, he probably just isn't something he wanted to do. This is a picture I just took. I was with a group of students up in Boston a couple weeks ago, and I just thought this was a really pretty greenhouse. They were doing collards production. You can see they're growing in grow bags on the floor, and you can see they basically have a Gothic style greenhouse, but fairly low tech. We like to talk about hydroponic production when we talk about greenhouses. This is a hydroponic lettuce operation in Columbus, Ohio. Lettuce is one of another sort of low entry, relatively easy crops to grow in greenhouses and hydroponically. Again, it's a fairly short window crop, right? So if you have a problem, it doesn't take long to flip those tables over and put a new crop in. And it's also highly marketable, highly valuable. Everybody loves lettuce. Even people that don't like vegetables generally like lettuce, right? And so there's a really good market for that type of thing. Now, one of the things that's also nice about growing lettuce in the greenhouse is it's a very short stature crop. It doesn't require any trellising, right? And so you don't necessarily have to have a super tall greenhouse for that. You just need to have enough space to put those systems out. On the flip side of that is our high wire tomato production systems. So here you can see this greenhouse is really tall, right? They're going to be training those vines up high into the sky. And there's other reasons that it's tall too. We're going to talk about thermal mass later and why that's important. The other thing you can see, this picture was taken in Greece, right? And Greece gets very, very hot very early in the spring. If you look at the size of the cooling pads on this greenhouse, they're huge, right? And they're also very tall. One of the things we're going to talk about later is where you want to locate vents and louvers so that that cool air can draw across the canopy of the crop. If you're growing very tall, high wire crops, you want to make sure you have a very tall cooling pad so that it can, distribute that cool air throughout the plant. I know there's a lot of interest in cannabis production in greenhouses these days. We've grown some CBD hemp out at the research station. This is actually another picture from Greece. This is a CBD grower over there, and we had fun interacting with them and learning about what they're doing. You can see they're growing in grow bags. It's a large gutter connected greenhouse, and again, in Greece it gets very, very, very hot. So this isn't something we would typically do in Kansas, but you can see they actually have sidewalls that are open which again is, from an IPM perspective, can be a little bit sketchy, but in that case, they're really prioritizing the ventilation of this house so they can just get it cooled off during the summer. Okay, so I put this table together, and I'm sure it's not perfect, but I think it's kind of a helpful guideline for thinking about, what you want to grow and how that affects what you need with the greenhouse. So we talk about hardening off transplants and really basic transplant production. You really just need minimal heating. Oftentimes, ventilation on that is with sidewalls or the hoop house is open to air. But oftentimes we also install ventilation fans and louvers like we do in regular greenhouses. Shade cloth is really can be important in those situations, and we'll talk about shade cloth later and why it's so important for transplants. But you can see, basically the longer the season gets for each of these types of crops, and in many ways, the more valuable are, then the more likely that it is that you need to buy something that costs a little bit more. I do see there's a mistake in my table here under fruiting vegetables. It should say tall structure with an X right here, so I apologize for that. We're not going to talk about this very much, but it's also worth mentioning how you will grow things is also important. We've talked about hydroponics already. You can see many of these hydroponic systems are self-standing, so they don't necessarily need benching to put those on. And oftentimes they don't need concrete because, there's nothing underneath of those systems except just a better way to drain it with gravel. And we'll talk about that a little bit later. But it does become important, trying to think about if you're going to be using hydroponics or other systems, because oftentimes those things take up space within the greenhouse, or you need to build a shed right next to it in order, to mix the fertilizers. I have seen some hydroponic systems that use direct injectors, but then there's others where they use mixing tanks, and so you need to have space for those mixing tanks. A lot of it just depends on the size and the scale of your hydroponic system. Aquaponics, that's another step up, right? We're going to have fish involved here and have tanks of fish, oftentimes within the greenhouse, sometimes within small buildings, either built inside the greenhouse or right next to it. And, one of the things we want to keep in mind with fish is that they need to live 365 days a year in some type of comfort, at least unless you're harvesting them and taking it out of production. So that means you need to have some type of very reliable heating system to make sure those poor fishies don't freeze in the wintertime if something bad happens. It also means you need to think about how you're going to keep them cool during the summer. The greenhouse, you can shut it down and take the tomatoes out for a few weeks during the hot part of the season, but you don't want to move that whole tank of fish, right? And so you need to think about where you're going to put those, where you have space for them, if you need to think about providing a secondary shelter for them. Okay, so some basic design principles are really, surrounding the idea of microclimate modification. So within the greenhouse, we always want to maximize the amount of sunlight that's getting to the plants, and all of the coverings that we use are going to cut some of the sunlight down, and we'll talk later about why that's important. But it's also important to recognize that during the wintertime, you have a lot less sunlight than you do during the summertime. So if you're going to be doing a lot of winter growing, if you're going to be, growing those really long-term transplants, geraniums and cuttings and those types of things, right, then you might want to make sure you're maximizing the sunlight with your covering, or even using supplemental lighting. Temperature is obviously a big deal. We think about the greenhouse, it keeps things warm at night when it's cold. And again, working with industry reps can be really helpful. What they're going to do is they're actually going to take the air volume of your greenhouse and they're going to calculate how many BTUs of furnace are needed to maintain the range of temperatures that you want. And they have pretty straightforward ways of doing that. So it's not actually as difficult as it sounds. Airflow is really important not only to cool off the greenhouse, but also within the greenhouse to circulate air and help reduce the chances of this nasty guy right next to us here, known as Botrytis cinerea. So this is a fungal plant pathogen. It's really problematic in almost all types of greenhouses, and partly because it has a very wide host range and it's a necrotrophic pathogen. And so what that means is it feeds on brown tissue, essentially. Once plant tissue starts to turn brown and dying, it's going to colonize that, it's going to sporulate very rapidly, and it's going to spread very quickly. So, if you've ever worked in a greenhouse, oftentimes we spend a lot of time what we call burping the greenhouse, where we actually ventilate it during the winter time in order to reduce the humidity and find other ways, even the way you arrange your plants or the pruning that you're doing with them, in order to reduce the humidity around that plant and reduce the chances of getting botrytis. Another really important concept to think about when designing greenhouses is thermal mass. So thermal mass is basically this concept, and it applies to any building, not just a greenhouse, that as the sun heats it up during the day, it's going to store that heat similar to a battery, right? And then at night, when it starts to cool back off, it's going to slowly release that heat back into the building. And the building's ability to do that is really based on the materials that it's built from, the amount of free water, which is we won't get into too much today. But in the case of greenhouses, what's really important is the total air volume. Okay, so as that greenhouse heats up during the day, the larger the air volume is, the slower it's going to heat up, right? And then at night, the opposite is the case. The larger the air volume is, the slower it's going to cool back off. So this becomes really important, especially when you're talking about winter growing and also summertime growing, because really difficult thing to do in the Midwest is to keep greenhouses cool during the summer. This picture is another one from one of our growing growers host farms, and you can see this is basically a south-facing greenhouse, and there's quite a few people across the country that have built these. Essentially, they take advantage of the angle of the wall over here to catch as much sun as they can, and then along the north wall, they do anything they can to increase the thermal mass. So in this case, Tom and Rebecca, what they did was they put all these water barrels along the north wall. They're going to catch all that heat during the daytime, and then at night they're going to release that back into the greenhouse. And I've seen lots of, folks do things like this or something similar. If you read at all about some of these Chinese greenhouses where they build them into the side of the hill, it's basically the exact same concept. You're increasing your thermal mass by a significant degree. And keep in mind that water has a much higher specific heat than air does. And so it actually absorbs a lot more energy, and it's able to radiate that back out at night. Now, if you read about thermal mass, people always talk about it as a heat battery, but I like to think about it in greenhouses as more like lung capacity. The bigger the lung capacity is, you draw it in, right? Whether it's the heat or the cool air, and then it takes longer to push it back out, right? And over the course of the day, it can be really cold at night, and then it gets really warm in the day, especially here in the Midwest where we get really drastic weather changes. What that's going to do is having that larger lung capacity is going to slow down the breathing, right? It's going to keep the greenhouse from hyperventilating in some ways, and it's going to keep those appliances like your fans or your furnaces. It makes them run for longer periods of time. It warms things up slower, cools things off faster, and it's easier to stay in an ideal range when you have an optimal thermal mass. This is a really cool greenhouse. I'm going to show you another picture of it later today. This is over at Boys Grove Farm in Kansas City, Missouri. And they just built it this year. It's a beautiful greenhouse. You can see it gutter connected, Gothic style. Another design principle that becomes really important is the orientation of the greenhouse. And I get a lot of questions about this, whether we want to make it east-west or north-south. Um, and there's two main factors that are important for that. Light is the number one factor, and oftentimes what people think about first, although that may or may not be the best plan. During the wintertime, when the sun cranks down to the south, it's going to come in at a sharper angle towards into that greenhouse. And so during the winter, you really want your greenhouse to be east and west in order to maximize the amount of light that it's receiving, because that light is not only good for the plants, but it's also energy to help keep the greenhouse warm. So in terms of light, that's probably the best. As you can see in this picture, this is our greenhouse range, I guess you could call it, at the research station, our three little greenhouses. You can see we have some that are oriented north-south and some that are east-west. And I can tell you the ones that are north-south, they grow perfectly good plants. I do find that along the eastern edge of this house, things dry out really fast in the morning. If we have plants sort of up against the angle of that hoop, those sides of the benches will dry out really quickly because they are just getting, direct sun right on them. But otherwise, I've been in lots of greenhouses that run north and south, and people do just fine with them. What I think is more important than light is prevailing wind. And so here in Kansas, our wind generally runs from kind of southwest to northeast, but for the sake of keeping things sort of directional, more or less south to north, right? So with these greenhouses, we have fans on the north end, right? And that includes this one along the sidewall. And then the vents, in this case, are along the south wall on both greenhouses. And what that does is it draws the air with the same direction of the prevailing wind. The last thing that you want to do is get into a windy day in May and have your fans fighting 30 and 40-mile-an-hour winds when we get these warm fronts that blow up, right? And so it's really important. I mean, I think very, very critical to always locate those ventilation fans basically on the north side of the greenhouse, no matter which direction it's being pointed. Okay, so let's talk about some of the different structures now. I think most of us are fairly familiar with hoop houses, right? These are often just more or less high tunnels with furnaces, right? And they come at generally a very low cost, and they can be used to harden off transplants or even grow transplants once we get into the warmer part of the spring. For more traditional greenhouses that are used for more winter growing, we basically have two styles that are common, the Quonset style and the Gothic style. There are A-frame greenhouses that exist. I love this picture of this greenhouse. This is another picture from Boston. And look at this greenhouse and the framing that's on it. It has I-beams in an A-frame style. This greenhouse could probably get 3 feet of snow dropped on it and it wouldn't flinch a muscle because it is so strong, right? I mean, if you look at those I-beams up there, and because of the way the A-frame is going to be shaped, it's also going to shed snow really quickly. That being said, A-frames are not very common for most farmers or commercial growers because they're generally just not they're not cost effective on a per square foot basis. We also have gutter connected greenhouses, and we're going to see some more pictures of those today. And that's essentially what happens when we take multiple bays of greenhouses and connect them together into one very large air mass or thermal mass. And obviously, that has a lot of benefits in itself too, but it has some drawbacks as well. So, one of the things I always find myself telling people is we forget that oftentimes that a greenhouse is not really a building. It's really a stationary piece of equipment. And that greenhouse oftentimes has as many moving parts, as many electrical switches, as many things that need to be greased and lubed as your tractor, right? And it's important to think of a greenhouse as that instead of just a building. Buildings we don't have to maintain unless something happens. But greenhouses, we generally have to be proactive at maintaining those. And part of that is just inspecting things all the time, always walking around and looking at stuff and making sure that it's working properly. So in terms of the components of the greenhouse we're going to talk about today, we're really going to focus on sort of the infrastructure of the greenhouse itself. And so stay tuned on these last few topics. They'll be covered in a webinar at a later date. So Quonset style truss greenhouses are probably the most common greenhouses that we see here in the Midwest. We do have a fair bit of snow here in the Midwest, but we don't have tons and tons of snow like they do in the Northeast or the upper Midwest. And so generally, Quonset style greenhouses are what people end up utilizing. They are the least expensive because of the way the hoop is bent. It's just less expensive than making a Gothic one. But unfortunately, they oftentimes can be a little bit prone to snow damage. So, you think about when it snows, um, snow is going to start packing on top of this hoop, right? And unfortunately, with Quonset style, you can get quite a bit of snow that can build up right at the top. And as it builds up, it's going to stick to itself, right? And so, because of that, they're way more likely to have trouble shedding snow. They're also just a little bit less strong against wind than the Gothic style as well. Now, one of the things we always want to keep in mind is we think about Quonset style greenhouses and hoop houses as sort of just this giant hoop that goes from the ground all the way to the roof, right? But in reality, the Quonset is actually just the truss. And you can build a Quonset style greenhouse at any height. So this is a 10-foot sidewall greenhouse here, right? And so it's going to be nice and tall. It's going to have a big air volume. You're not going to have any problem growing tall crops up against the side. This Quonset style greenhouse here is very much at an angle, right? It's a prefab job, and so you're going to have troubles on the sides of it with tall crops. You could have some issues with snow there as well. Now, I did want to touch on a little bit what the truss does within the greenhouse. We often look at those things and we're not sure what they're doing, but they very much do have a purpose. So, and again, I'm not an engineer, but the way it's been explained to me is essentially as snow builds up on top of, say, this corner right here, instead of it just crumpling in that tube, right, it's going to push on these supports, right? Which then are going to transfer that push down to the truss cord. Okay, so what that does is it basically distributes that weight, and instead of, this tube trying to hold 500 pounds of snow, this tube is being supported by this whole network of tubes. And keep in mind that on this side, it's attached. And so as this pushes down, this side is actually going to pull up against it, right? And so they balance each other out and help keep it rigid. And no matter if you're talking about a Gothic style truss or a Quonset style truss, that W webbing that exists between the trusses is actually incredibly important. And it was really interesting. One day in our greenhouse, we had a big snow, and we do have a gutter on both sides of our greenhouse, and so it tends to collect snow up this side. And I was just amazed. You could actually see the snow pushing down on the truss a bit, but where you could really see it was on this truss cord was like a big S, right? Because it was getting pushed from this side and pulled from the other side. And so it's really interesting. You can physically see how that thing actually was distributing that weight. So what about this greenhouse? This thing has no trusses, right? I just went into this big tirade about how important they are. So this is sort of a transplant greenhouse, hoop house. But one of the things that's important to note about this frame, and this is a Nexus frame, so they come from Colorado where they really deal with snow, is that this frame is made from square tubing. It's not round tubing. Square tubing is much stronger than round tubing is. So if you start looking at greenhouses or especially used greenhouses and you see ones with square tubing, that's a good sign because they're typically much stronger than round tubing. So Gothic style is sort of the other major style of truss that's used for greenhouses. And in Gothic style greenhouse, it's basically going to have a pointed roof, right? And this makes it stronger and more resistant to wind. And in the same way snow pushes on the greenhouse, wind does the same thing, right? And it helps distribute that pressure amongst the truss. Um, so this is a picture from the Cultivate KC Stowe Farm up in Kansas City, Kansas, and they just got done building it. You're going to see probably a few more pictures of that later today, but they have a nice Gothic style greenhouse here. And this was a fairly inexpensive greenhouse. They did build it themselves, so they were able to save quite a bit of money that way. But you know, Gothic style are definitely stronger, and because they have that point, they shed the snow much better during the winter time. This is back again at Boys Grow. You can see I've got a lot of greenhouse envy for this place. So they not only have the Gothic style trusses, but these are also square trusses. And I bet you this greenhouse could take a huge snowstorm and also be able to withstand that. The other thing that this greenhouse has is, and you can't really see it very well in this picture, but we'll show later, is it has a roof vent. So the roof actually opens to let hot air out of the peak of the roof. And you're not able to do that very well with a Quonset style arch or truss, excuse me. You really need the Gothic style truss in order to use a roof vent. So gutter connected houses are exactly what they sound like. We essentially take a frame of a greenhouse and put it right next to another greenhouse and then put this gutter in between them. And that's sort of an oversimplification. As you spend more and more money on greenhouses, they have fancier and fancier framing systems that make all that work together. I thought this one was cool because it literally is two greenhouses bolted together with the gutter in between, and it works quite well. Now, one of the nice things about these gutter connected greenhouses is that they have a huge thermal mass. You have a very large air mass there, so it's going to warm up slow in the morning and it's going to cool off fast in the evening. And those are both advantageous things because you don't want temperatures to swing very quickly in the greenhouse. On the flip side of that, it's huge, right? And so even though this is probably more efficient than other greenhouses on a per square foot basis, if all you need is 200 square feet to grow a few transplants, there's no reason to heat up this 4,000 square foot house, right? And so even though it might be the most efficient, it may not be what you want because you just don't have enough plants to fill it, right? And that becomes really important with these large greenhouses. The other thing with gutter connected greenhouses is that they're going to all be the same temperature within that area. And as you learn more about growing plants in greenhouses, you'll find plants love different temperatures. And it's one of the reasons that nursery operations are like 40 oftentimes a whole bunch of small greenhouses compared to one large gutter connect, is because they want to be able to grow things at different temperatures. And there's some logistical issues. Obviously, you got this gutter. Think about all the water that comes off of this roof and into that gutter when it rains. You have to find something to do with that water and to drain it and get it away from the property in a safe and environmentally sustainable manner. The other thing is maintenance on these things. This is from when we covered the one up at Cultivate. you can see Mark and his crew, they're up there walking in that gutter. And it does take a certain mindset to be able to walk in the gutter of a greenhouse. That's not something everybody can do. Thankfully, this particular greenhouse has a really wide gutter. It's much wider than the ones we have at ours. And so that makes it a little bit easier. I oftentimes get questions about putting in concrete versus gravel. If you've shopped around for greenhouses, you'll know that putting a concrete floor in costs almost as much as the frame of the structure itself. And so it becomes a really big decision. Do I want to use concrete or should I just have a gravel floor? I'm a big fan of sort of doing the compromise. This is actually a picture of our greenhouse out at the research station. And what we did is we actually put a concrete sidewalk in where people are going to be walking, where we're going to be moving carts up and down, but then left the rest gravel. And there's a lot of reasons for that. Not only the cost, but part of the cost is you have to build this whole drainage system with concrete floors. And not only does that cost money, but then maintaining it can be a problem. And I've been in greenhouses where they've gotten clogged drains and, like a swamp ensues in the bottom of the greenhouse. They don't realize it because it's underneath benches. And pretty soon you've got a fungus gnat problem, and then you've got a smell issue. Like all kinds of things can happen if that drainage system fails. The nice thing about concrete is you are able to use radiant heating systems. We're not going to talk about those today, but there's really one of the nice, efficient ways to heat a greenhouse. But then, again, the advantage is one of the things to consider is if you're going to have people in your greenhouse other than your employees and or your family. If you're having visitors on a regular basis, keep in mind you probably want to be ADA compliant. And again, that's where something like a concrete sidewalk's really helpful because it allows everybody to be able to get through, even if they can't get to every square inch of it. One of the things I've seen a lot of our greenhouse growers do that are growing vegetable crops like tomatoes is they'll put fabric over the gravel. And in this case, they're using white fabric so they can also not absorb as much heat and also reflect some of that light back into the canopy. And I find that is also really a nice way to address the issue of the unlevelness and make it easier to walk. It also is much easier to clean than gravel, but at the same time doesn't cost nearly as much as putting in concrete. The other thing I don't like about concrete is once you have a concrete floor, you can never dig into it, right? If you have a plumbing problem and suddenly need to run a water line from here to there, in this situation, you can just peel up that fabric, dig out the gravel, and run your water line. If it's a concrete floor, you are stuck with what you have, right? And so that's another big challenge with concrete. The covering and the glazing, right, is also very important for, um, you know, decisions that you're going to make when you're talking to folks about building or buying a greenhouse. I love this cute little greenhouse. I actually used to work in one just like it when I was in graduate school, sort of a side job. But most of our commercial greenhouse growers or farmers are not going to be using glass because it's just obviously very vulnerable to hail damage. And here in Kansas, we have hailstorms that pop through all the time. And I could tell stories, but there are greenhouse businesses that have gone bankrupt because they had glass greenhouses. A big hailstorm came. They could never replace, the cost of replacing all those glass panels. Not to mention the mess and the potential danger, right? And so we want to stay away from glass. Acrylic is also glazing that's used for very, very high dollar greenhouses. I don't think a lot of our beginning farmers are going to be using that, but if you're interested in that, you can look up acrylic or plexiglass glazing as well. Now, when we think about the covering, we want to talk about light transmission. That becomes really important. We also want to think about trying to provide some type of insulatory value to keep the cold out because deep winter growing is going to require that. And also just maintenance and installation becomes really important. So probably the least expensive way to cover a greenhouse is going to be with a double layer poly film, right? And that's basically when you have two 6 mil pieces of plastic, you use this nifty little inflator fan to shoot air in between them, and it creates this bubble. And I apologize, this is a picture of a high tunnel, not a greenhouse, but I think it's just a great picture of you can see how that bubble is inflated And what that's going to do is it's going to provide some insulatory value in the evening time to help hold in that heat that's within that building, right? So the other thing that's nice about having double layer, and I don't know that I would ever use a single layer in something we call a greenhouse and we're actively heating. But because once you have this nice tight bubble, it's going to be more resistant to the wind. And one of the things you want to keep in mind is as the years go on, if you get holes or you have problems, your fan goes out, when that thing goes slack and becomes loose, then you start having problems, right? And so you want to make sure you maintain that bubble to the best of your ability. Here's a lovely picture of some hail damage on polyfilm. Obviously, this is not what we want to see. The good news in all this, unfortunately for this grower, they had to replace the poly. But what typically happens is even with big hail, it will oftentimes stretch through the first layer and not penetrate the second layer or not penetrate it all the way, right? And so oftentimes you just have to replace that top layer if you do have a hailstorm. And in general, and I know in this case, all the plants that were in this greenhouse were safe and saleable, and this grower didn't lose any money except for the cost of replacing the plastic. So, keep that in mind that it's usually not a total disaster when you do have hailstorms. It's just a big pain in the rear because all of a sudden you got to replace the poly. Clear corrugated plastic is used really more so for high tunnels than it is for greenhouses or for sort of like hardening off and hoop house, less expensive greenhouses. It works really well for in walls, and we've got a greenhouse at our research station that has clear corrugated for the in walls. I don't really like it for the sidewalls, although I have seen that used before. It's just kind of hard to work with. It's very thick, and the way you have to sort of finagle everything together to get a seal can be difficult. But with the in walls where you can put a piece of flashing over the front of it, it works fine. And this is basically the same material that you can get that's used for like skylights and pole barns. Obviously, it's a single layer of plastic, so it's not really going to provide any insulatory value, but it is very inexpensive, pretty easy to replace if you have any issues. And again, it's a nice thing for sort of your low cost greenhouses. Twin wall polycarb is what's used on more of your higher tech and more expensive greenhouses. So this is essentially uh, just like corrugated cardboard, except it's made out of plastic. And you can see a nice picture here on the right, the way it's made. There is an air gap that exists between two thin layers of plastic, and that again provides you with a little bit of insulation. Now, the nice thing about twin wall polycarb is it lasts a very, very long time, typically almost as long as the greenhouse will. Um, and it also has much better light penetration than polyfilm does. You can get in a couple different thicknesses. I often tell people for a high tunnel, use the 8 millimeter. For a heated greenhouse, use the 10 millimeter. But you don't have to follow that rule necessarily. The 10 millimeter will give you a little bit more insulation. Now, we oftentimes discuss or get the question about using these for the roof, right? And this is going to be a very durable material, so it's going to be very resistant to storms and hail, which is really nice. But at the same time, it can be difficult to do maintenance on it, 5 and 10 years after you've built it. If you are having issues with a leaky roof or a damaged panel, it can be a little bit challenging to deal with. And over time, it will actually yellow. It tends to do that before it breaks down itself. And this is usually why it would get replaced is it becomes opaque and it's not able to transmit as the light as well. So this is our grafting greenhouse at the research station, and this is some pictures of when we were building it. You can see we use twin wall polycarb for the in walls and the side walls. One of the things I also really like about twin wall is it's actually remarkably easy to work with. Basically, a circular saw with a plastic blade or a little Dremel tool with a cutting blade. You can cut this stuff in any shape or way that you want. It's very similar to cutting cardboard. It's easy to measure. It comes in nice sheets that are fairly easy to work with. It's a lot thinner than the corrugated stuff in terms of trying to get it up there and mounting it. And so I think it's very friendly for do-it-yourselfers or people that are trying to build it, although it oftentimes looks a little bit scary at first. Now, this twin wall polycarb is held together by these H channels, and you'll end up talking to a salesman about what these are, but they're basically aluminum strips that hold the polycarb where it comes together. And then you attach those H channels to your framing. Just, sort of a comment about glazing and covering. Again, this is a picture of our greenhouse at the research station. And one of the things we decided to do was actually put a poly film on the roof. So we have sidewalls and in walls with twin wall polycarb or rigid plastic, essentially. But we didn't want to do that on the roof. At the time that I bought this greenhouse, it would have added about $20,000 to do that. And it takes me about $1,200 and a calm morning with a few people to replace that roof. And I said to myself, you know what, I'm probably not going to have to replace this roof 20 times or 17 times in the next 20 years, right? And so one of the ways you can look at it is like you can put all your money into that roof with a rigid roof now, or you can put your money into the roof slowly over time by replacing that polyfilm. And so that being said, we work at a place where we have a great crew that's able to do that, and we have the tools and the know-how to do it. I work with like a lot of school gardens and school greenhouses. They don't have the ability to replace the roof, right? And so for them, it's going to be better to have a rigid roof because it's a lot lower maintenance in the long term. But that being said, if you do have a problem with twin wall polycarb and it's right here, think about how difficult it's going to be to get there, fix that problem, fix that leak. Whereas with polyfilm, you have something happens, it rips, or a hailstorm, you just put a new piece on. Ventilation is obviously really important in greenhouses, especially if you're going to be trying to grow during the late spring and summer, or especially if throughout the summer, right? But it's also important in wintertime, and we'll talk about that here in a few minutes. There are lots of different types of vents that we can use. The most common are really shutters or louvers, like metal shutters, or rigid vents. So those are the two main ones that we're going to talk about today. I have seen some greenhouses with drop-down sidewalls. This is actually a greenhouse in Arkansas where it's a little warmer climate than we have. And the thing about those is, boy, it's really hard to button down those sidewalls and get them sealed up really tight in the wintertime, right? They're going to be very leaky. So if you're trying to grow in January in Kansas City and we have negative 12-degree weather, it's something with a sidewall is not going to work out very well. So these would be your metal louvers or what we call shutters oftentimes, and you can determine the size of those by working with, your sales folks, and they'll calculate that based on the air volume that's within the greenhouse. Notice that we want to put these shutters at the height of the canopy, right? So that we draw air across the plants. This is another type of vent. This is actually at our research station, and this is kind of unique. It's this drop-down curtain that's really designed for like swine operations, like confinement swine tunnels. They use them on the sidewalls, and for whatever reason, they built this one to as an opening or a big shutter for the greenhouse during the summer. It generally works pretty well. We have some issues maintaining it. But I don't see those around very often. I just thought it was kind of neat. We can also put our louvers on the sidewalls of the greenhouse, and we might talk about that a little bit later. Keep in mind that if you're ventilating a greenhouse from side to side as opposed to end, you're gonna have a lot of hot air that builds up here, right? And we'll talk about that in some of our later webinars when we talk about heating and cooling inside the greenhouse. But it's something to consider for sure. So in general, and keep in mind our prevailing winds are going to be going the same direction as this arrow. We're going to be drawing air in from one side and ventilating it out through the other side. And it really doesn't matter if you're going across the side to side in the greenhouse or end to end. It makes no difference. It's essentially the same idea. Now, if you are going end to end in the greenhouse, I highly, highly suggest having a fan up here in the gable. And these become really important, especially during the winter time, because if you have a sunny day in January or February, it might be 20 degrees outside, but it quickly gets to 90 degrees inside the greenhouse. And a nice way to ventilate those is by having this gable vent and have that come on first so that it's not pulling a massive amount of cold air across the plants. What it's going to do is it's going to help escape that hot air from the roof, and the air that comes in is going to circulate with the air that's up in the top of the building, and it's going to help reduce the temperature a little bit more slowly than just kicking on a fan right here that's straight in line with that plant canopy. Rigid vents are sort of the next major type, and these are used typically for greenhouses where you have cooling pads in place. This greenhouse I visited was really neat. It provided me with a great opportunity to get a picture of a rigid vent without a cooling pad. It's so hard to get a picture of a rigid vent from the inside to see what it looks like because they're always covered with cooling pads. But essentially, with a rigid vent, you essentially can build these to any size you want. You basically use aluminum or other metal to form a frame and a door, and then you cover it with twin wall polycarb just like you do the sidewall. And that vent's going to open, and it's going to be a much larger opening than a traditional shutter or a louver. Obviously, these are more expensive. And they do come along with some maintenance. You do need to make sure that all these little gears and fittings are staying greased and that they're all operating in the right way so they don't get bound up. So they have a little bit more trick to them and a little bit more maintenance to them than a louver, but especially if you're going to use a cooling pad, they're really helpful. This is a picture of our rigid vents from the outside. So basically what happens is a motor turns this tube. It's going to spin, and then when it spins, it's going to draw these bars out and open this door or this big flap essentially to let the air in. And one of the things that's nice about rigid vents too is because they're typically much larger than a louver or a shutter, we can open that vent up and not turn on a fan on a cold day, and it's going to really slowly cool off the greenhouse. You should have some circulation fans in there anyways that are going to help draw in some of that cool air. And so typically, like in the wintertime, it's not uncommon in our greenhouse for this rigid vent to open up. It cools off the greenhouse and then it just closes again, and it never turns on the suction fan or the ventilation fan because it's large enough that a fair bit of cool air can just slowly make its way in. So this is a picture from the inside, and we're not going to talk about cooling pads today, but just wanted to let you know that the reason that we make rigid vents much larger than we do shutters and louvers is because when we put this air through this cooling pad, it's going to slow down, it's going to cause resistance, it's not going to allow as much air to get drawn through. And so for that reason, we have to make that opening much larger. Roof vents are one of my favorite things. I unfortunately don't own or don't get to work in a greenhouse with a roof vent, but I have spent some time in them. And what's great about these is they use the same basic mechanism or technology as a rigid vent. It's just located up on the peak of the roof. And there's some, like the one at Boys Grow, that opens on one side. This is at a large transplant nursery, and he has a beautiful greenhouse. And you can see it opens all the way at the top like a cathedral. And what that does is it allows all that hot air to escape. And it's really remarkable working in greenhouses that have roof vents because they're passive. Once this roof vent opens, all the other ventilation fans turn off because you don't want to draw air in through the roof. You just want it to let the hot air out, right? And so they're really quiet, and it almost makes you feel like you're sort of halfway outdoors when you're there because you look up and there's sky above you. It's really interesting. But this is a great way to get hot air out of that gable. Okay, we'll wrap up with shade systems and hopefully have time for a question or two. There's lots of different shading out there. Typically, white or black is what's used. In higher tech greenhouses, we'll use reflective shading. And for most vegetable or transplant production, you're going to use anywhere from 30 to 55% shade. And it can be mounted externally or internally. You can see this is some green shade cloth that they were using when I was over in Cambodia a few years ago. Incidentally, this is actually not a greenhouse. This is a screen house, right? And so you think about the climate in Cambodia, they don't need a greenhouse. All they need to do is just keep the bugs off of the plants because the temperatures are just fine there. Now, these shade cloth can either be fixed, oftentimes outside or external in the greenhouse, or they can be automated. Obviously, this is a very low-tech greenhouse here. It's really common. This is a transplant grower, so he's going to have perennials and annuals inside this greenhouse. And that shade cloth is really important for carrying over those transplants because they're in tiny little pots and containers. And so they dry out really, really fast once we get into May and June, right? And so in particular, this grower is using 55% shade. That's pretty heavy shade and probably as heavy as you'd ever want to use for growing transplants or vegetables. We have white green shade cloth on our greenhouse that we utilize during the summer. One of the things that's nice about it, it's not going to absorb as much heat. Now, external of the greenhouse, I don't know if that makes that big of a difference, but it does change a little bit of the light characteristics as well too. We chose to use 30% shade because we didn't want to cut it down so much. We've done a lot of research, more so in high tunnels than greenhouses, that really shows when you cut down too much light, you can have issues with nutritional quality and other things. And so we're always trying to practice what we preach. And for that reason, we really don't utilize more than 30% shade cloth in our tunnels or our greenhouses. Internal shading systems you can see are going to be fixed up to the ceiling. They're usually right underneath the truss cord and they're going to run along the top of the greenhouse. And you can imagine in that situation, that black shade cloth absorbing heat becomes very important, right? Because during the day, it's going to be absorbing that heat and keeping it inside of the building. Now, most of our internal shading systems are going to be automated. So what that means, these pictures, these are fixed. So they're really just strung up there and held tight, more or less for long periods of time. In this case, they're basically built like shutters. So you're going to have short lengths of shade cloth that are distributed across the ceiling of the greenhouse. And then those are going to open and close based on what the controller says. So these become really important and helpful in very hot climates. Also, if you're trying to grow things like fruiting vegetables through the summer, you know, high-end, high technology shade system becomes really critical and helpful. They're also being used a lot these days as an energy curtain. So we actually close them at night and it helps keep the air warmer underneath of them. And so they can provide other benefits as well as shade. Incidentally, this is a greenhouse in Abu Dhabi. You may or may not recognize, these are actually air conditioning units inside of this greenhouse, which I thought was just the wildest thing I'd ever seen in my life. Okay, so kind of to wrap things up, greenhouse can benefit a farm in a lot of different ways. One of the things we want to do is plan for our environment. And I tried to show a lot of examples today from different climates and different places around the country and the world. And, I didn't point it out earlier, but, look back at those pictures and think about what those people, in Greece, it's really hot. In Kansas, we get hot and cold. In Cambodia, it's really humid, but it doesn't get cold at all, right? And so thinking about the climate and the challenges that you have. In Boston, it snows like crazy, right? Get yourself a nice Gothic style greenhouse that's going to be able to withstand that force. Think about what you're going to grow. Again, this becomes so important. The dimensions, the structures, the ventilation systems, everything about that piece of equipment that you're going to build on your farm is really dependent on what you're going to use it for. So really put some thought into that and understand that if you change direction, what sort of the consequences are of that. Will this greenhouse be able to adapt to my needs if I change it, right? Understand this is a long-term investment. High tunnels are very inexpensive, and we often talk to growers and say, oh, they pay for themselves in 2 years, right? With a greenhouse, it's going to take longer to do that, and you should be prepared for that and think about how you're going to cash flow that piece of equipment, because it's really important to get a high quality greenhouse in order to accomplish the goals that you want to. We want to maximize our thermal mass, so that's part of it too. When you're investing in this greenhouse, you probably don't want the exact size greenhouse you need today. You need the size greenhouse that you're going to grow into in the next 2 years, right? And that might be getting a bigger greenhouse, which is also going to help you manage the microclimate in there by having a little bit larger thermal mass. And don't be afraid to seek out help. Again, there's a lot of folks in extension. Keep in mind, greenhouse in Michigan or in California or in Mississippi is not all that different, or at least many of the activities that happen within it are not all that different than here in Kansas. So utilize national resources. They really are very useful for controlled environment ag. And again, I have learned so much about greenhouse design and structure from industry folks, the salespeople that work with these things every day. All right, so thanks for your attention today. I really appreciate it. It looks like we just have maybe a minute or two for questions. We do have an evaluation that we would love it if you all could complete. And so thanks again for joining us.
So it looks like we have one question. Somebody asked, are there or sorry, two questions. First being, are there any institutional resources or apprenticeship volunteer opportunities in the Oklahoma City area?
Yeah, I'm not sure about Oklahoma City itself. I can tell you that Oklahoma State University has a very strong horticulture program, so I would reach out to folks that are there. I personally don't have any connections there, so I can't really help with that.
And then the last question, is there a better color to use with the twin wall, white, clear, or bronze?
Ah, that's a great question. So yes, I'm very glad that question got brought up. So there are greenhouse companies that sell bronze and opaque twin wall polycarb. The reason they're doing that is because people are using it like sort of as a head house in their greenhouse, or they'll put it over a storage area, or maybe where your aquaponics section of the greenhouse is going to be. Those those products are not made for growing plants underneath them. They don't have the light transmission that you really need for that, unless you're going to be using lighting, or you're doing light deprecation with cannabis or some of those things. You really want to just stay away from those.
Any other questions? I'm not seeing any in the chat, so there might not be any more.
Well, that's all right. It's 3 minutes after 1. So thanks for joining us, everybody, and I hope you have a great rest of your day.